So, unfortunately, I'm very sorry, but yeah, I don't have any slides for you tonight. But I would like to. What did it mean? I would like to talk a bit more about the GopherCon, because first thing first, it was just incredible. They just awesome to see that many people coming together for the same event, and it's just I have been to the previous one, and it's just magnificent. So. We had quite a few interesting talks during that GopherCon, and the first one actually, the entrance keynote was by Francesc about the NIL, and the NIL is actually very interesting for those of you who did a bit of Go. I'm pretty sure you're familiar with NIL, but are you? Because NIL is actually untyped. And what does that mean to be untyped? Like if you put any variable to NIL, if it's a pointer on interface, it's going to work. If it's a map or a slice, it's going to work. If it's a native type, it's not going to work. But my point being that NIL could be a channel, a map, a slice, a pointer of anything, and it does not really have something. But it has some very interesting properties. A simple one would be like for the slice. A NIL slice, what is a NIL slice? It's nothing. But if you have a slice that is NIL, meaning that it has a type of slice and it has not been instantiated yet, you still can do things like append, len. So like a len of a NIL slice is going to be 0. Append on a NIL slice is going to actually instantiate your slice and append what you have been asking to append to it. It's very wonderful. Like one caveat would be the NIL map, because you cannot affect to the NIL map. It's going to panic because it's a hash map, and that is a bit annoying. But typically for a slice, having the NIL value can allow you very easily to, on one side, check, okay, like do I have something or nothing, or like has been associated or not, and check the length. And on the other side, you don't really worry if it's NIL or not, because you can append to it. So that is pretty great. Another case would be the channels. And typically, when you associate a channel and you wait on your channel as a receive is going to wait for the other side to send, that is expected. But what happens if you receive on a NIL channel? A NIL channel would be kind of a panic, like a seg fault for those of you who know C, but actually it is not. Like if you try to receive on a NIL channel, it's going to wait forever. So that can be a very interesting behavior in a select. Like if you select 2 or 3 channels or more, and some of them are NIL, they are just going to wait forever. But some other case might unblock before that. So that is interesting. And a NIL channel is not to be confused with a closed channel, because the closed channel has nothing to do with the NIL channel. And a closed channel, if you read on the closed channel, is going to unblock all the time. So like if you put that on a select or on a loop, a NIL channel is never ever going to block, and is always going to return the default value of the type. And so that's something to be very careful about, because typically if you clean up something, and during the cleanup you close the channel, or if you close the channel and then affect the channel to NIL, it's going to be to have very different behaviors, and so that's something to worry about. And but that NIL can be used still as a channel in a select block to be able to say, okay, maybe I don't care about those statements and I care about the other ones, and I'll be able to unblock on the others. Another interesting use of NIL would be the types and the method. Typically, if you have a type controller with a method start, for instance, and if you call start on that type pointer to controller, which is NIL, the start, a decent developer coming from C or a language that's similar would say it it needs to take fault. However, it does not. It's just because of the way Go is structured, like what is going to happen, because the type itself is not nil, and you have the type controller, is going to call indeed your method, but with a nil receiver. So that is also a very, very nice use case of nil, is that if you have a type that does not need to start with a given state, you can start from anything. You could handle the nil receiver inside your object and return the new version of it or whatever you need to do based on that. So that is also a very, very nice use case of nil, is to use it as a receiver. So you can, so basically you can do the nil dot something if it's typed, and it's going to call your method with a nil receiver, and then you need to manage to make sure that it's going to work. So that was the first Gopher keynote by Francesc, and if you have any question on nil, feel free to ping me. Another one that I would like to talk about was the Go Guru. The Go Guru, that formerly was known as the Go Oracle, is basically the most indispensable tool for any developer, beginners or more advanced, because Go Guru is going to help you to see everything. And when I say everything, I really mean everything. Like, imagine you have an I/O reader. So it's a read interface coming from the I/O package, which has a single method, read, that takes a buffer and return the number of byte read and an error. If you take any reader with Go Guru, you can pull up every single types in your Go path that implements that interface. And on the other way around, if you have a type, you can see any interface that implements that type. So I'm thinking about a very simple use case, NetHTTP. And personally, I really don't like NetHTTP, even though it is very, very powerful, but it does not return an error. And I like to be able to return an error and not to worry about it, and to be able to do like a write header and whatever. So what we did at Leaf is that we have a small wrapper that we call eHTTP, and what it does, it extends the NetHTTP package with an error return. But in order to do that, you need to know like what does NetHTTP do. And like in order to do that, we can see inside the code, thanks to the Go Guru, that it has a response type that is not exported and a HTTP2 response type that is not exported as well. But we can see that they are there, and then when you go to them, you can see all the interface that they are supposed to implement. And then because of Go Guru, it becomes very easy to just re-implement everything that is supposed to be implemented, and because it does not even need to be explicitly called, and like as you know, in Go the interface are passive, and like you don't explicitly say I'm going to inherit from that class and have all this method. Like any type that implement methods implement that type. So like you don't really have that explicit hierarchy that you would have in C++ or in Java, and like in order to do that, Go Guru is going to do that reverse tracking for you, and it's going to help you and to let you know that indeed NetHTTP is going to implement, for instance, the close notifier, the reader from, the flusher, hijacker, and all that. Those are just a small methods that are implemented by the NetHTTP package, and if you want to extend it, like you can have the single already exposed interface which is like either write header or write, but it's not going to allow you to do like a WebSocket, for instance, because you don't have the hijack. It's not going to let you do like a server-side event because you don't have the flush. It's not going to let you know when the customer, when the client is gone, because it doesn't have the close notifier. And Go Guru is going to help you do all that. And also it has a very good advantage, is that it is very well integrated into any editor. It works just fine with Emacs, just fine with Vim, just fine with Sublime. I suspect it works fine with Eclipse and some others as well. And but basically it's very well integrated. And if you just jump into a code that you don't know, like to be able to know like where is your interface call actually getting called and not just jump to the interface definition is a very, very huge advantage. So you can know like, okay, this call is actually goes there, and not this call is just an interface that could be implemented by anything. It's like very, very practical. So there's a few caveats to this, is that right now we still need to set the scope. And this is a bit annoying, but basically anytime you try to look up something, what it's going to do is going to compile and to look up the AST and like to do everything. So the first constraint is that your code needs to compile. The second is that like you need to set the scope, and like depending on where you are, the lookup is going to be different. So like if you need to be in the scope with a main or some test, and like let's say you're on your custom project, so it's going to be your gopass/src/your test, and if that's the main, it's going to look up everything else. But we do need to set the scope, because depending on where we are and what the scope is, like that lookup is going to be different, and this is really like a pure static analysis. And my big recommendation to anyone would be to use GoGuru. Finally, I had a third one that I wanted to talk about, but I forgot.
I have a question about GoGuru. Why did we get rid of the Oracle and then did GoGuru?
Because there's a tiny company that has been taking over the name. Yeah, and like because of that, they had to rename it into Guru, and like Oracle was a bit too common, I guess, and so now it's Guru. But basically it's the same thing. If you go Guru, go Oracle, it's the same thing.
If you want a good study just in how to deal with abstract syntax trees, Guru, look at the source code on GitHub is awesome. Source for that.
It's pretty good, and like also like it was not really in the GopherCon, but speaking of which, like Go has an awesome AST library, because Go compiles itself, and like you need to have an AST in order to compile and to Lex and to whatever. But it's you have an awesome tool called GoGenerate that can pre-compile your code, and that GoGenerate can leverage all the power of the AST library that the compiler itself uses. And this is how GoGuru works, is that it's just going to do like a full-blown static analysis of your code, just like with the compiler, and come up with like results that are understandable by your editor, so you can like jump anywhere and see everything that is going on. And well, I really forgot my third one. Not a big deal. Let's talk about something else. Any question on anything first? Okay, so let me think. The assembly code. The assembly code has been a very, very awesome talk about assembly with Rob Pike, and this is like one of the magic thing of Go is the assembly. And like I would suspect that most of you are not really familiar with assembly, but something that you must know about assembly is that it is really like basically the lowest level where you can go, and it's always like very much platform specific. However, you know that Go is really platform, can support easily the cross compilation, and in order to do that, it uses its own version of assembly. And when you compare like the actual assembly code of like 20 versions of different CPUs and architectures, you notice that it's always very, very, very similar. Maybe not the same keywords, not the same length, but it's always very similar. And like what the Go assembly is doing is that it basically provides a platform independent, so like a portable version of the assembly. And that is just the most incredible thing that Go has done to me, is that it really provides to the developer a platform independence and like a really portable way to do assembly. And like, so no matter what is the platform, after you do have indeed your actual assembly compiler that is going to transform into the proper instruction, but the assembly for all the infrastructure in Go, it's always the same. So that is also like a very great point of Go, is that you can write in assembly, you can very easily extend your assembly, and it's like something that is common and that's going to be understood by the two chain in order to do everything. So that's my talk.